Well, welcome everyone to our 7th Scalable Pandas Meetup. I'm so excited to be here with all of you, and we're really thrilled to have Chris Fregly here with us today. So, agenda: we'll briefly recap meetup goals. We'll do some quick introductions, and then we'll jump into the main event, which is Scalable Pandas in AWS. Let me count the ways, and then we'll turn the time over to Alejandro to ask some questions of Chris, and then we'll open up for audience Q&A. So these meetups were formed with the goal of talking about complex workflows, data science workflows, and in pandas, and working with large data sets and trying to come up with solutions to addressing those challenges of scale. Who is Ponder? Ponder is the enterprise-ready pandas company. We're the primary maintainers of the open source library Modin, which is 4.5 million downloads. We are working towards a future of sort of pandas on everything, pandas on any backend. The thing we're working on right now is pandas on SQL in a data warehouse, which is pretty cool. Why did Ponder start these meetups? We did this to try to create a community around discussing the challenges that come from working with pandas at scale, and also sharing case studies, talking about best practices. We hold these typically once a month, usually on the 4th Thursday of every month. This month is different because of Thanksgiving, and then we won't have one at the end of December. The next one will be later in January. If you want to get involved, you can email me at peter@ponder.io. Okay, well, I'm so excited to get to introduce Chris and then our interviewer, Alejandro. So Chris, Principal Solution Architect for AI Machine Learning at AWS. He's co-author of the O'Reilly book, Data Science at AWS. He also is the founder of the Meetup series, Data Science on AWS. So Chris is an extraordinary person to talk to about scaling pandas in this AWS context, and also just working at scale on AWS. Also, we're happy to have Alejandro Herrera here with us today. He will ask Chris questions after Chris presents. And Alejandro works at Ponder. He's a solution architect. He's previously worked at C3 AI, and he worked in ML consulting. So I'll turn over to Alejandro for a second if you want to add anything, just introductions, and then after that we'll hand it over to Chris. But Alejandro, is there anything else you want to add?
Yeah, I'm excited to be here. Thank you, Chris, for joining us. Super excited to hear what you have to share with us this week, especially on the heels of the Glue and AWS SDK Pandas announcements at reInvent this week. Obviously, you and I know each other, and whenever we go for drinks, I get to hear all of your war stories, going back to even your Netflix days. This half-page intro definitely does not do you justice. For the broader audience, would you mind just kind of giving a little bit more color on your experience in the data stack and kind of career and what led up to your joining AWS? That would be awesome.
So I moved to the Bay Area from Chicago about 12 years ago. I went straight to Netflix. And I think, Alejandro's probably thinking of the time recently he and I went out, and I was explaining, I didn't realize what scale was until I got to Netflix. I was working for a pretty high throughput website in Chicago, and realized when I moved to the Bay Area that high throughput in Chicago, or at least the stack that I was working with, was nothing compared. I mean, it was like multiple orders of magnitude different at Netflix, and to the point where you can't just grep logs, because you have 5,000 streaming servers, which is what we had in 2011, and now I'm sure they have, because we had 20 million customers back then, 15 to 20 million. Now now Netflix is at 200 million. So they have a lot more streaming servers. It's not possible if you're trying to find an error, for example, to just go onto a single machine and then grep for the error. You have to run Hive queries and Spark queries and stuff. So, and that's when I realized databases don't really help out in those situations. Can't really, yes, you could use bigger and bigger Oracle clusters, but at the end of the day, you have to switch to some kind of MapReduce or, some sort of distributed processing. Yep. And then I went to Databricks, learned Spark really, really well. And then did a short stint at the IBM Spark Tech Center where I helped build that out. And so that then evolved into an AI center. And from that point, I left and did my own startup called Pipeline AI. And then 3 years after that, I ended up joining AWS and bringing through some of the code and the experience from the startup. So yeah, today's talk, it's a bit tongue in cheek. In fact, I adapted this from a talk I did internally recently for my colleagues within AWS calling, scaling Spark on AWS. And the subtitle was "Let Me Count the Ways," because what we realized over the last year trying to improve Sagemaker. So Sagemaker is the Amazon machine learning service, and there's a bunch of subservices and features and things in there that complements the big data. And the big data services like Athena, and yes, I'll show all this here in a bit. Things like EMR, the Elastic MapReduce and stuff. But what we realized was we had Spark spread out in so many different products and services that it's confusing to customers, and it's still going to be confusing. Yeah, after this talk, I can't guarantee that things will make more sense. But one of the things me and Ansha tried to do when we were writing the book was cut through one slice and show, and this is 500 pages, so this is not a light read, but take one use case and just cut through all the different layers: data ingest and data streaming and security and all the distributed training and hyperparameter tuning and in that we also discovered from the book that there are just so many ways to do Pandas, so many ways to do Spark. And today I just want to show you what I see as some of the more popular ways to use Pandas and Spark even, and I'll talk about Ray also. And this reference to Cheers, there's actually, I was Googling because I couldn't remember if this phrase comes from Shakespeare or where. So yeah, it's "How do I love thee, let me count the ways" by Elizabeth Barrett Browning, one of her sonnets. And also, sort of interestingly enough, I checked IMDb, IMDb came up in the Google search, which is an Amazon product. And there was an episode of Cheers actually in 1983, which unfortunately I was alive for, season 1, episode 14, "Let Me Count the Ways." And I guess Diane becomes upset with everyone at the bar when nobody shows any sympathy after she learns that her family cat has died. I can't remember this episode. I was like 10 years old at the time, but it was probably funny at some point. Okay, so I'm going to take a tiny bit of a diversion, but it is sort of related. So I'm going to talk about some of the updates from reInvent that actually happened this week. And a lot of these releases actually happened yesterday, which is really interesting, which is why I've been up all night, trying to debug certain things and, figure out what's going on. Also, I do want to talk about the Amazon CodeWhisperer. I saw someone in the chat called out Copilot. That's by GitHub, which is hosting a model within Microsoft and Azure Cloud. Yes, Amazon has something similar called CodeWhisperer that actually plugs in to VS Code. And yeah, I do have demos of a lot of this stuff as well too, that we'll get to throughout. And so CodeWhisperer will actually fill in code. So I can just write a comment and say, read Parquet data from S3 using Ray, and boom, all the code is generated. And I'm just tabbing through and maybe changing the name of the a bucket within S3 or the name of the CSV file on my local laptop. Really, really powerful stuff, and something that you should definitely try. This will be transformative, as a couple of us pointed out, for basically all engineers and scientists, analysts for the next 5 years. Also talk a very, very high level about the AWS services for data, AI, and machine learning, just to give context for some of the terms. And then we'll jump into what's called the AWS SDK for Pandas. This is a library. This is not a service. It's an SDK that is built to interact with pretty much all of our, databases, data stores, time series databases, S3, Athena, Redshift, for like data warehousing. So it's one massive SDK that has been heavily optimized by the like AWS solution architects, people like me, and folks from professional services, which are some of the smartest people within AWS because they actually are working on a day-to-day basis building end-to-end projects for customers. So that library AWS SDK for Pandas is very, very like heavily used within AWS. And also I think there's about 3,400 GitHub stars. Pretty much all customers I deal with today are using that library in some form. It really encapsulates a lot of best practices for security and for performance and concurrency, things like that. Last, we'll get to Serverless Ray on AWS. And that's actually something that was released, I believe, on Monday. And I knew it was released because I got a text message from Alejandro saying WTF on like Monday morning. I thought it was actually going to be released like, later in the week, like today or either Tuesday, Wednesday, but apparently Alejandro knew before I did. So, but I did manage to get it into the slides and the demos today. I was just talking with Alejandro, I think yesterday when we were preparing for this about the Glue service. Glue, it's so funny because like no one really talks about Glue, but so many customers use it. So many, and at a minimum, it's where the Glue data catalog lives. That's the service where our Hive meta store lives. And if you're using Spark or using Hive or using any old Hadoop or whatnot, you are rightly using some sort of Hive meta store. And so our managed Hive meta store is called the Glue data catalog. So at minimum, people use the Glue data catalog. And then now that the data has been, all the metadata, for your CSVs that are living in S3 or your log files or your RK files, once all that's in the Glue data catalog, now it's really easy to use the Glue service, which has managed notebooks. They were kind of crummy before, just to be perfectly frank. They have deprecated the old Glue dev endpoints for the few folks that know Glue. They're still supported. They're just in a different section now. In fact, you can go in there into the console right now and see that most of that stuff is moved to the bottom and called legacy, which actually is the first service I can remember in the history of AWS that has actually called something legacy. Normally AWS has this sort of backward compatible habit of just keeping everything around, but the Glue service, they really have been pushing things forward. So they now have much better Glue notebooks, Glue scripts, Glue drag and drop, so I can drag and drop my flows. And not a lot of people know this. And I have to be honest, I didn't really know about it either until I joined AWS. I always kind of laughed at the name Glue because I thought it was a ridiculous name, and I just thought people used it for the data catalog. But the more and more I've been working with customers, Glue is almost everywhere. And you could do Ray now from Glue, as of just this past Monday. You could do Spark, and I'll talk about one of the really cool innovations about Glue, this thing called the interactive sessions. So Glue, so it's GIS, Glue interactive session, where I could start up a Spark cluster within seconds, up to 50, like 100 nodes. And it uses this technology, this open source technology that was built by AWS called Firecracker. And Firecracker actually, powers Lambda and powers Fargate and some other stuff. I'll get into it here in a bit, but just know that, Glue actually is a very heavily used service. And I think will become even more so with its new Ray support and these, really fast Spark startup. So real quick here, updates. lot of focus. My job this year was really focused on SageMaker usability, and then collaboration, the ability to collaborate. This is something we see in, our partner products, places like Databricks. They've had collaboration in their notebooks for, many years. And finally, notebooks as jobs. So I can actually launch a notebook. In fact, if you saw my screen earlier before this started, I was testing out one of the jobs. And this seems so obvious because places like Databricks have been doing notebooks as jobs for many years. Finally got to the point where there were like enough customers asking for this that we finally implemented it. The really cool thing is that the notebook as job, because SageMaker Studio, which is our IDE, which is based on Jupyter Lab, because it's based on open source, we actually contributed back to the open source. And so now you can actually do notebooks as jobs just from basic Jupyter Lab. That does mean that you have to manage your own Jupyter Lab, and so there's some downsides there. But just know that we do have a Jupyter committer, one of the like early Jupyter committer and like Jupyter Lab like committers that work at AWS. He's a very high level here within AWS, and he's very open source focused, and he's done a really good job working with the community to sort of co-create this. And then of course we build our SageMaker extension, but you don't have to use SageMaker. If you don't want to, you can just run these notebooks as jobs yourself. And some of the collaboration comes from there as well too. And that was co-developed with the community. The other thing for this year was a really large focus, or first-class focus for large language models and large like generative models. You might have heard of something called Stable Diffusion for sort of generating these really cool images. There's a lot of cool demos out there to do it, so won't really cover it today. But and then on the large language model side, a lot of support for BERT and for GPT, and all of these, and Bloom is now the like massive large language model, and those are all part of what's called SageMaker Jumpstart, which the name wasn't my favorite at the beginning, but after a couple of years now, I've kind of gotten used to it. So that's where we're putting all of our sort of quick start or like jumpstart models, where I just want to pull up this pre-trained model, point it to my data and make some predictions. Let's see how this thing is bouncing here. Okay. And then finally, my favorite, besides the SageMaker usability, which I think has become much better, but Serverless Ray. So the ability to launch a Ray cluster, and we'll talk about Ray some more here in the context of Modin and distributed pandas. But yeah, the ability to actually launch Ray clusters in a serverless manner, just spin up what I need, just run my job, and then tear it down. And I could do that through both SageMaker and Glue. Okay, CodeWhisperer, I was kind of teasing y'all earlier. I want to highlight, so I just started typing this, and I was doing this last night around midnight. I just said, train XGBoost model. Well, actually before that, sorry, I said visualize data. And I had this data set from the Pima Indians diabetes data set, which I found online. And I just typed, visualize data set. I typed load data set. It popped up some sample CSV. I typed in the CSV that I want, told it header equals 0. But 100% of this code was generated off comments. Well, I'd say 99.9 because I did have to make a small change to the CSV to pull the one in that I wanted. And this actually plotted, used matplotlib. It knew all the imports. It told me what needed to be pip installed. And so this is me and I'm in VS Code here, and I'm just typing, what I want to do, right? The sort of declarative, this is what I want to do. And then this code pops up around me. Now here's a slightly more complicated where so I just typed train XGBoost model. and it said, okay, what's your data set? Okay, CSV, boom, boom, boom. It did all these imports itself. So CodeWhisperer is now generating code for me, and it's based on the context. So here it knew that I was visualizing this data set. So it like automatically filled in this data set, knew that it was a CSV. So it used a limiter comma, knew that there was a header. So it gave me skip rows equals 1. Here it's splitting the data. I actually forgot to do the evaluation. And when I was done doing the predictions, I just hit tab, and it started to fill in the evaluation. And so, I was going to forget this step because oftentimes I do. I just want to try the model real quick and run some predictions and sort of, human eyeball it. And this said, no. Yeah, you want to use scikit-learn to actually, compare these to the ground truth and get a accuracy score. So this is a case where I didn't even know, what I was going to do with this, and this filled it in. So I've been pre-trained on millions and millions of lines of code, and pretty cool. Very similar to the GitHub Copilot project. Like I said, this is all generative models, and in this case for code samples. I put it to the test last night. It knows the AWS SDK for Pandas, which we have not yet talked about, but I'll show it here in a bit. Knows about Modin, knows about Pandas for sure. This actually knew about Spark. Let me see if I have it. I should have it up. I mean, I knew that it could probably do some basic stuff, some Python loops or whatnot, but it was pretty incredible. It knew Spark. So it was giving me probably more imports than I needed because I didn't actually use all these, but it was able to, read in CSVs. It was able to write out the parquet, right? Like, again, it knew which file I was using. It knew that it was a CSV with a header. Here it's going to write the parquet, and then I'm going to read the parquet. I'm just kind of playing around here. I said, show me the data, boom. I said, show me the schema. It, knows to use print schema and count rows. The other thing here is it knew so this is the AWS SDK for Pandas, which used to be called this weird AWS Wrangler, so it's still legacy called that. But this is what I'll describe in a bit. But this code was all generated by CodeWhisperer, and this plugs in as a VS Code plugin. You don't need a AWS like account or anything, so you don't have to provide a credit card or any AWS credentials. You sign up for this new thing called a builder ID, which is all you do is give an email, and then we can start generating code for you. It knew Modin. And what else here? Yeah, so let me jump back. So pretty cool, huh? All right, real quick overview of the AWS services. So the ones we'll be mostly talking about today will be Glue. And here's the Glue data catalog. Like I said, it's a Hive meta store is what this sort of general category. Basically, it's tracking, or you register the schema of the data that you have. And this way I can query it, through natural SQL syntax. And so I might have, CSV that has 15 or 16 fields, comma separated fields. I would register that schema one time and then point to any new CSVs that come in. Glue can actually crawl them and load that data into the Glue data catalog. And now when I run a query, it knows where to go in S3 and can index and, filter that data. There's this Glue sort of ETL. So this is what I was saying. Not a lot of people know about some of these features, the ETL. People do use Glue for the crawling of new data as new data is coming into S3, from your application, and it's being registered with the Glue data catalog. But there's also something called Glue Studio that is Jupyter based, and you can build notebooks, and it's pretty cool. And Glue Studio also has a drag and drop as well too, so you can actually wire up different transformations. That one I have not used that much. I haven't really gotten to the point yet where I'm doing drag and drop, but actually drag and drop is coming up more and more. The low code, no code is coming up quite a lot. So the EMR, this is the Elastic MapReduce. That's kind of an antiquated name, but this is where our Spark lives. This is where our Hadoop, our Hive, all of that lives here. The Athena, this is our managed Presto. So Presto is a query engine. Really all of these things are built to query data on S3. Yes, I would say Redshift is our data warehouse, service. And I can actually also query S3 from Redshift as well too. So I can have data in my data warehouse, and I can, maybe the last 10 years, and then I can have the last, like 11 years to 20 years in like S3 sort of colder storage. Well, I can run queries like between Redshift and S3. This is all covered in our book, by the way, and many videos online and talks online. The one we'll talk about mostly today is going to be Sagemaker, and we'll be using something that's actually not on this, which is the interactive sessions for Glue. So between those two, so here's Studio. This is what I'll be showing a lot of demos in. Up till now, just to be clear, I've only been showing VS Code and the CodeWhisperer, but in a bit I'll get into Sagemaker here, and we'll actually be using Ray through Glue. And yeah, I'll explain a little bit more how that happens. It's a tiny bit confusing, but okay. So before actually, as part of this, let's talk about the AWS SDK for Pandas. So something I did last night when I was building this deck was, let's Google for Pandas on AWS. The very first response, sort of ironically, is from Google Cloud, from like GCP tutorials. I have no idea why this is in there, so don't go to that one. Go to this, next one here, which is SDK for Pandas. I think this is actually 4 or 5 down. We have to do a bit of a better job on the like SEO, but this is where we want to look, and so that's what we'll be taking a look at. It's about 3,200 stars. Quick note on stars, by the way, because I did have a startup before coming to AWS, and that's kind of a funny story. When I was doing the VC pitches, what I realized was the VCs for a seed company were valuing, and this is 4 or 5 years ago. Each star was worth about $1,500 in seed funding, and so literally. They said, okay, if a company has, this many stars, we will give them this much money. And as I talked to more and more VCs, I sort of, fit the line and realized that they were valuing each star at about $1,500 in terms of the investment that they would give, not the, market cap or whatever. Okay.
Okay, I just want to say that is so funny. Also, really motivating to be like to your sister, your aunt, your cousin, like, hey, look, like, this is worth a lot of money if you just take a moment. That's so funny.
Yeah, good for the friends and family kind of thing. Yep. So capturing AWS best practices, that's what this library does. Like I said, this was built, maintained, not just by the community, but also by very, very bright like AWS solution architects and members of the professional services team. This guy, Nick Corbett, I think, Alejandro told me it just, popped into the Modin chat recently to say hi, that the latest version of this like SDK for Pandas includes Modin, which can run on Ray or Dask to do distributed pandas. And so I'll talk about that here in a bit, but so when you would use that. But just know that what we're doing here is we are providing this SDK. So again, this is not a service. This is a library that works. That the whole goal is to scale pandas to the cloud, and specifically AWS. That's what the AWS is in there for. And I'll get to that other slide here in one sec, but these are all the services that are supported by this library right now. So what's happening here is there's this sort of local API or this like library, right? This like SDK that I'm using that I can connect to these cloud services, run queries, using S3 or using these like backends, large clusters that are within, Redshift is a big one. And I don't have to run this query locally on my laptop. And in fact, I can't because the data set's too big, right? So, but I'm able to create a pandas data frame from the results of the query that I'm doing on this massive cluster in my cloud account, okay? So hopefully that makes sense. And, DynamoDB, that's our NoSQL, kind of like Cassandra. We actually do have managed Cassandra also, but, most AWS projects, we end up using Dynamo. And let's see, I can query my, MySQL server, which is Amazon RDS. I can query Oracle. I could query Redshift. I can, query my like EMR. So I can actually run a Spark job on my like EMR cluster, all from my, local laptop even, get the results. So all the heavy lifting happens back within my like cloud account. And I'm just going to return the results, maybe, top 10 products sold today or something like that. Okay. Backing up a slide, so why does scale matter? Well, like big data is big, right? And this was the key thing. I felt like such an idiot, I was young. Well, I was 37, I think, when I went to Netflix, and I was relatively young in my scale career. And we were doing all these Hive jobs, and I'm like, these things take like 35, 40 minutes. Why am I running this when I could just query a simple database? And my boss at the time said, Chris, this data does not fit in a single database. That ended years ago. When like Netflix first started and they were DVDs and there wasn't a whole lot of click-through data, there was add it to my cart or, add it to my queue. That was one thing, but I joined the streaming team, which was all of the interactions, the play, the pause, the, buffering, all of the, like, there were so many things happening that like needed to be tracked that could error out that we had to have this like insight into. Okay. So, that's when I realized, oh, okay, I can't just query a single database or even a single server, because we had 5,000 of these streaming servers out there that were, listening to all of the play events from, thousands of devices. And I specifically was on iOS and the like Android devices, which was really fun. Okay, and so data that doesn't fit into a single server's RAM needs to run on a cluster. And this also applies to a single laptop. And typically what people do is they sample the data just because it'll fit on their laptop. They get an idea. Well, like, you don't have to do that anymore. I can actually use the power of the cloud and run massive queries in parallel that take the same amount of time as my sample data on my laptop, but I actually get the real answer because I'm running it on all of the data. One other thing to mention is, I do mention clusters here. This is something I was speaking with Alejandro about just recently, which is, these days I see more and more folks using dedicated clusters per job or per sort of interactive session, right? So there's this, what I call the exploratory machine learning phase. It's similar to exploratory data analytics, but there's also this sort of interactive machine learning. And that's something that we are really moving towards with, Sagemaker Studio and with our Glue like interactive sessions. So, but the key here are, you really want to try to avoid these sort of shared, clusters. Yes, this bullet point should say shared cluster, or, dedicated cluster avoids the contention with, with these traditional shared clusters that have multiple users and multiple jobs. And this is how things were just because these clusters took so long to start up, or they took a lot of maintenance to just keep them running. But there's so many things that can go wrong, and like just debugging, this like massive cluster with all these different users, and trying to figure out which job killed that cluster. I remember in my next step to learning Hive and Spark, I had launched a query that literally took down our shared Hive cluster throughout all of Netflix. And I think I missed a where statement or something, or didn't put a limit, and my results were, I don't know, like 8 terabytes or something. And so this is trying to be streamed back to my terminal, and just took down the entire cluster. And so usually what people do in that case is they start to implement all these workload management strategies. Okay, well, the long running jobs get lower priority and the interactive job. So if you can avoid all that, then just, every user launches their own cluster, maybe for an interactive session for an hour or a couple hours, and then it'll tear down, or just do it per job. And so now that I've done my interactive, I've got my data, I'm exploring my data, transforming my data, and then training my model. All that can just be spun up and spun right down. And there's no more need to have shared clusters with all this sort of contention happening. Spent a very large amount of my early career trying to solve this problem. And it really wasn't until I'd say 2015, maybe 16, where these sort of per user clusters or per job clusters really started to come into fashion, and really requires a lot of automation or a managed service, like AWS offers, and these other cloud providers offer, or folks like Databricks. Serverless, also the biggest benefit for serverless, besides this being slick and cool and fun to talk about and fun to argue about if it's really serverless or not, the idea from the end user's perspective is I'm only paying for what I'm using. So it's not a long running cluster that may be idle, 70% of the day, and I'm still paying for it. It's only using what. So yes, there are servers behind it, but from your perspective, you are only paying for the fraction of time that you are using those servers. And one of the best, in like my mind, sort of innovations that really opened up a lot of use cases here is this project Firecracker. And I was so happy that like AWS actually open sourced this. It's still active. I mean, they didn't fork it and then forget about the open source project. It's still being used. This is what powers Lambda. This is what powers a service called Fargate, which is essentially an alternative to EC2, where I'm just paying for the time that I'm using. Just like I said, it's basically serverless like EC2, which is kind of like oxymoron. But if you check out Firecracker, there's a lot of use cases that have been, and because I can start up these serverless clusters within seconds, and in some cases less than 1 second, depending on if you have to do any pip installs or jar installs, whatever. But this is what makes these sort of instant clusters per user or cluster per job possible. Back in the old days, these clusters would start up in 10, 15 minutes, whatever. Yeah, where can I run this AWS SDK for Pandas library that we were talking about? I could do it on my local laptop. I'm going to be limited by the RAM that I have on my laptop. Fortunately, AWS gave me a 32 gig 3 years ago when I joined, which was a little bit out of the budget, but was able to convince them that I do big data and therefore I need big memory. And so, but we will actually focus more on the Glue notebooks. And I think just because of time, we will probably stick with just the Sagemaker Studio notebooks, which is what I spend most of my day in, that actually let you launch these serverless clusters in Glue through Sagemaker Studio. So this gives me serverless Spark and now serverless Ray as of Monday. The other place we see this pandas library running is inside of EMR Studio, which is, yes, if you notice, like we have Glue Studio, we have Sagemaker Studio, we have EMR Studio. I spend a lot of my day trying to convince people that we need to merge these. We'll see. Have to, give it another go next year.
If you were a practitioner listening to this, and I have all these different ways of interacting with these scalable serverless services, what are the trade-offs I need to be thinking about here? Should I be directly working with Glue? Should I be working with Glue through Sagemaker? Like, how should I make sense of this?
Yeah, the way I describe it, because right now one of the limitations of Glue and of these Glue sort of interactive sessions is they don't support GPUs, and that's because Firecracker does not support GPUs. I believe I actually can't remember if Lambda supports GPUs, but if the way to get around this, which we are talking through, is we would not use Firecracker if the user chooses GPUs. Like, we would fall back to the traditional EC2, which would be a longer startup time, but you actually get access. So the GPU roadmap for Firecracker is a bit out. Not sure how far out, but the short answer is, if you're doing anything with GPUs, or you want, sort of SageMaker pipelines, or you want like a model registry for your models, you want to do A/B testing of your models, stay within SageMaker Studio, because that's what supports all of the, bias detection, all that. If you just go into Glue, you get some nice drag and drop features and things, but it's not really the main place to go for machine learning. If you're just doing data analytics and wanting to put transformations together, Glue, Glue Studio, Glue Notebooks, Glue Jobs is a great place to be. Yeah. If you're doing that only to do machine learning, you want to stick within Studio. Yes, EMR Studio, I really haven't used it much. There's a serverless option as of last reInvent 2021 that I think finally GA'd this year, I hope anyway. So I haven't really gotten a chance to play with that, but the one I will encourage on is to find the serverless solution. There's now Red Serverless as well, where you can pay for just what you need, which is really nice. Serverless data warehouse, really cool. Ray on AWS. So why does Amazon care about Ray? This is something that Alejandro asked me yesterday, so thought I'd put a slide in here. Amazon.com is actually who, within AWS, really started using Ray, and this started, I think, 2 years ago. They were looking at Ray, which was not even 1.0 at the time, to do some pretty specific use cases. Change data capture was one, and Ray was actually giving better performance than Spark. Now, we had to make some modifications, and that's this blog post here, where we actually detail some of the contributions that Amazon.com gave back to Ray to make it scale for terabytes, petabytes. So and the performance for some of these use cases just blew Spark away. Now, Spark is still faster right now than Ray for things like true sort of analytics type use cases. My guess is at some point will something like a Ray SQL. I went to the Ray Summit this summer, and people were actually asking on stage during keynotes. I think it was the director of AI from Uber that said, look, we are willing to replace all of our Spark with Ray, but we need Ray to get better on all the normal analytics use cases, aggregations, things like that, group buys, all the things that require shuffles. And so beyond Amazon.com, around the same time, more and more customers were asking for that same thing, where they They had really good experience using Ray for things like hyperparameter tuning or for reinforcement learning. They wanted to extend it to more AI workloads and also to more data set workloads, more sort of data transformation workloads. So check that out. The open source blog gives a little bit more insight into that. But as you can imagine, a lot of the AWS services actually stem from the high scale needs from our sister company or whatever, the sort of commerce side of our business. And so once like Amazon.com starts needing something, we build it out. And then we say, hey, this is really good for the rest of our customers on the AWS side. And then we formalize it and turn it into a service. Yes, I can say that this happens so much faster than you think it could possibly happen. And I'm not going to go into the details, but this definitely happened in the 3 years that I've been here on like multiple occasions. And this, Ray making this service, like this can happen so quickly within AWS. It's just absolutely amazing. All of the infrastructure is already set up, all of the web service, all the security layers, all the pen testing. It's so there are so many mechanisms that this can happen very, very quickly. So, super cool to see that actually go from end to end. So, of course, we've been talking about serverless. Let's talk about serverless Ray on AWS. As far as I know, there is no serverless Ray offering in the market today at all. This came through under the Glue product line, but we can get to it from Sagemaker. And so this is actually Sagemaker, and that's what my demos are through. But I'm actually, my kernel is pointing to a Glue interactive session. And this is what gives me the ability to, I could say, max workers. I don't have max workers in here, but I could say max workers is 50, and the Ray cluster will actually auto scale up to the number of max workers. Okay. So also, yeah, and so just to be clear, although this is actually through Glue, I can do machine learning workloads, non-GPU at this moment, but I can do my CPU machine learning workloads using the latest version of Ray, some of the AI runtime or Ray Air. Okay, and so real quick, these are all the services that support Ray right now. Serverless, the recent serverless is Glue. There is Ray support within EKS. I have examples of all these on a repo. For those of you familiar with EC2, this really is what a lot of the early examples of Ray, but this is server full, right? SageMaker, of course, supports Ray as well. I really like this chart here. The cool thing about Ray is I actually can scale a job from my laptop into a cluster with just one line of code change. I just say point sort of locally in my Ray init. When I connect to the cluster for that session, I can connect locally. My cluster is just my local laptop. I change one line of code and I'm pointing now to a cluster. Threw that in from another presentation that I had. A couple more slides. Do we have time? Yeah, a couple more, just a couple here. Really cool comparison here. Ray datasets, which is their specific to data loading and data transformations. They do some really cool stuff here with parallelizing. Took about 7.5 seconds to do this group by and count. Did this again with Modin, even faster, 7.2 seconds. Now I do it with Spark, and it's almost 19 seconds. And so this is why I'm saying the overhead of a JVM, Spark is getting a little long in the tooth now, like originally designed, like 2010, 2009 kind of thing. And I would much rather do this much quicker and 7 seconds than 18 seconds. All right, data processing, AI machine learning, probably leave those. And here's Modin. So this is using the latest. Here's showing the APIs that from the AWS SDK for Pandas. I had said earlier that we now use Modin for distributed pandas. These are the specific APIs that are supported as of today. You can look in GitHub here. There's a link on how to actually debug any issues that you see or performance. You'll stumble upon this if you Google any error message that you get from using this SDK for Pandas with Modin. Okay, and I think that's it. Really, the only demo I wanted to show here real quick is doing PyTorch. And I could run it here. Let me see if we get that one going. And so this is doing PyTorch with Ray. I could do TensorFlow with Ray. I can do XGBoost with Ray. The one thing I'll say about Ray is it uses the GPUs like so much more efficiently than I've seen with just regular XGBoost or regular TensorFlow, regular PyTorch. One of Ray's strengths is a slide that I skipped over here, which is the last mile data loading is what it's commonly called. The benefit here is it's jamming the GPU, it's saturating the GPU, yes, unlike really any other framework I've ever seen. And recently we saw almost 99% utilization of the GPU, which I thought was a mistake, but we went back and then verified it. When we weren't using Ray, we were getting 40%. And so there's a clear value prop using Ray, which is I'm actually going to train twice as fast because I'm actually using my GPU twice as much. So that concludes.
Thank you, Chris. And I know we're a little bit over time, but Peter, do you want to field a couple questions from the audience?
Yeah, we had a couple. First of all, thank you so much. This was super information rich. I'm definitely going to go back over it multiple times and think through everything you said. We had a couple of questions. One of them was from Kartik. It was asking about the AWS SDK in particular. Does it wrap Pandas functions with custom operators, or does it just provide Pandas functionality within AWS services?
Yeah, it's the best way to describe it. I've been going back and forth on how to describe it, because interestingly enough, the very early versions of this SDK for Pandas, they were actually found themselves re-implementing Spark, which they knew was not the right thing to do. So the short answer is it's adapting, it's handling all of the things in the background to serve up a data frame. And so this is why I was a Pandas data frame. So the end user, passes data frames in and gets, or, queries or things in and gets data frames back. But it's using all of those services to fulfill those queries. And so the thing that you have to be careful of is if you're doing a query and you're returning a whole lot of results back into your notebook, it could still crash. And this is something I would deal with customers at Databricks all the time. Back when I worked there was people were connecting Tableau, for example, to their Spark cluster. And they just thought that they could return all of the results back to Tableau. Well, of course, that's going to be slow. Of course, Tableau is going to crash. So the data frames, now this is a really simple toy example for the two. Let me actually find a better example here. So the short answer is you will still be limited by memory on either the inputs that you're passing in or the result sets that come back. So, this is actually doing a select all from this CSV. This is 58 megabytes. It's going to pull it all back in to this running context, which in my case is a really small two, CPU. Oh, yeah, let me get the example. Two CPU, 4 gig. So if I have a result set here using this, that's more than 4 gig, this is going to fail. And so the way that we would tell customers for the Tableau Spark thing was make sure that you are doing heavy lifting in Spark, but only returning, the top like 100 sales or some like large aggregation that's shrunk down to just a few rows or under whatever memory you have. Now I can certainly change this instance type, and one of the slides I had hidden here that I will unhide is these are some of the high memory instance types within AWS. This is incredible. I actually didn't even know this. I remember there being a 2 terabyte instance type. That's not even listed here. That's not even considered high memory. This is a 24 terabyte single instance within AWS. So I can scale vertically. Now, of course, these are ridiculously expensive because there's so much compute, 448 hypercores, hyperthreads, and then 24 terabytes. I could certainly do that, but it's not really recommended that you use these larger instance types because you don't really need to typically. So it's just thinking about things differently. I think some people think once I have distributed, I can still return all these results in my notebook and do things. So yeah, that's the only caveat.
As a follow-up to that, though, one really quick question is Modin, if you exceed your RAM, spills to disk. So if Wrangler is taking advantage of that, like does Wrangler take advantage of that spillover capability?
I don't think so. Oh, well, if it's using Modin, yes. And the Modin tutorials will be, because, yeah, how do you turn that on, Alejandro, within Modin?
I think it's on by default.
Yeah. So if that's the case, then that's the same thing that'll happen, right? Okay. This select query actually does that. This is what is using Modin beneath the covers. And so I can run this real quick. It'll tell me what my engine is. So yeah, that's a very good point. So this is starting up. This is making the connection to the Glue session. Then it's going to import Wrangler. It's going to spit out what, which of the execution engine, if it's going to be Dask or Ray. And then it's going to run. So here's engine Ray. Memory format, enum Modin. Yeah, so this should do it.
Chris, so I think we'll do one more question and maybe conclude. But we also had a question from, I don't know how to say the name, but Bashith, who's a PhD student researching smaller scale GPU clusters or doing research with smaller scale GPU clusters, and wanted to know how to get started learning about AWS offerings there.
Yeah, we have this awesome, what's it called? Sagemaker Studio Lab. You could do this for free. I'll put the link in here. And you actually have access to GPUs. You get them, I believe, for 8 hours. Free account, you don't need any credit card or anything. I have a sign in here, remember me. And what you can do is you can select CPU or GPU, use GPU, click start runtime. You have it for 8 hours. This is totally free. You can go crazy. And yeah, that's a good way to do it. The sort of next level, like Studio Lab is single node. And so the moment that you have to go beyond single node and start to scale out, that's where you'll need to sort of upgrade to the SageMaker Studio, which this notebook costs $36 per month. This 2 CPU 4 gig. So if you have $36 per month, you can go crazy. The cheapest GPU, I have to look, I'd say is probably $50 a month, something like that. But the Studio Lab is totally free. And Studio Lab actually does let you schedule notebooks now too, as well, as of this week.
Thank you, Chris. That's awesome. I think we'll pull it to a close. But Chris, thank you so much. This was amazing, super interesting, and I'm really excited to pour over it. All 100. Anything else you want to say before we close?
Thanks for joining us.